Hi, don't forget to check out my course for the Quant section of the CAT exam, where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail. Hi everyone, this is your next question from CAT 23, the third slot. Please pause the video and try solving it before you look at the solution. So it's a very easy question if you are aware of the basics of quadrilaterals and polygons. So let's start. In a regular polygon, interior interior angle exceeds the exterior angle by 120 degrees, then the number of diagonals of this polygon is. Okay. So guys, for any regular polygon, or rather for that matter for any polygon, the number of diagonals can be given as n into n minus 3 divided by 2, where n is the number of sides. Okay. So here I need the value of number of sides of the given polygon. For the number of sides, I've been given the hint about the interior and the exterior angles. So using the interior and the exterior angles, I'll first figure out the value of n, and then using this particular relation, you can figure out the value of number of diagonals. Okay, so let each interior angle be equal to x degrees and each exterior angle be equal to y degrees. Okay, the difference has been given as 120 degrees, right? So x minus y has been given to us as 120 degrees. Okay. Next, when you take any polygon, guys, let's suppose I take a regular hexagon for that matter. If I draw a regular hexagon, I'll notice that the interior angle and the exterior angle, they form a linear pair, right? This you can observe for any other polygon as well. You can take a pentagon also and verify the same fact. This is one interior angle and this is the exterior angle. They always form a linear pair. So remember, for any polygon, the interior and the exterior angle, they're always supplementary. So x plus y will be equal to 180 degrees. Okay, so now you can basically add or subtract these two equations to figure out x or y. Either of them will do my job, right? So if I, let's say, add these two equations, y will get cancelled out and I will get 2x is 300, or I get x is equal to 150 degrees, right? Now, in geometry, we have studied that for any regular polygon, the measure of each interior angle is n minus 2 into 180 degrees divided by n. Okay, and this we have found as 150 degrees. So I can solve this further to cancel out 0 0 from both sides, or just cancelling out 30 from both sides. I'll get this as 6 and this as 5. Okay, so 6n minus 12 will be 5n. Okay, giving me n is equal to 12. Okay, now since I've got n equal to 12, the number of diagonals will be 12 into 12 minus 3, 9 divided by 2, and that is 54, right? Alright, so that's one way out in which you add these two equations and you directly get the value of x. And once you get x is 150, you can get the value of each interior angle. You can use it to get the value of the sides, and then you can get the number of diagonals. Okay. Now let's look at the other way, a slightly simpler way in which I'll subtract these two equations. On subtracting these two, I will land up with 2y is equal to 60 degrees, or y will be equal to 30 degrees. So y means the measure of each exterior angle of this polygon, regular polygon. And for regular polygons, we know each exterior angle is worth 360 degrees divided by n. This we have found as 30 degrees. So very instantly you'll end up with n is equal to 12. Okay. Okay, and then the rest is very, very clear to you, I guess. N into n minus 3 upon 2 is the number of diagonals, that will be 54. Yeah, so that's how you solve this given question, a very simple one, and the answer is 54.